Welcome to qnawire.
An object that is 14 centimeters from the vertex. The object is on the optic axis, and the image is formed at 9 centimeters from the vertex, but in the liquid. And it's important that we know that the image is in the liquid and not in the glass. So, two important things right away is that the radius of curvature for this concave rod is going to be negative. So that's what less than 0 means. And the object distance, or the image distance rather, S primed, since it's formed on the side of the incoming rays as opposed to the outgoing rays, it's going to be negative also. So these are two very important things that we need to keep in mind when we try to find the index of refraction of the liquid, which is what we're asked to find in this problem. And we're going to use equation 34.11, which states that NA over S plus NB over S primed is equal to NB minus NA over R. Now our goal is to find NA, so let's do some rearranging here. So we have NA over S plus NA over R is equal to NB over R minus NB over S primed. And we can pull out these NA and NB since they're in the numerator. So we can write that NA, 1 over S plus 1 over R is equal to NB, 1 over R minus 1 over S primed. And we can just put this over a common denominator and also this over a common denominator. So that gives me NA times R plus S over R times S is equal to NB. And now I have S prime minus R over S prime R. And then I can divide both sides by this R plus S over R times S so that I have NA by itself. So I have NA is equal to RS over R plus S times S prime minus R over S prime times R times NB, of course. And actually, I can just cancel out those two R's, so then I'm left with S times S primed minus R over S primed times R plus S times NB. I'll actually write this on the next page so it's clearer. So what I just wrote there is NA is equal to S times S prime minus R over S prime times S plus R. All of this times NB. Now we're given that S is 14 centimeters. So this is the object distance from the vertex. We're told essentially the magnitude of the image distance, but we have to keep in mind that it is negative. So that's minus 9 centimeters. And since our glass rod is concave, we know that R is also negative. So we also know that MB is 1.6. So we have all the numbers that are necessary to calculate an A. So I'm just going to simply substitute. So that's minus 9 centimeters. That's minus 4 centimeters divided by minus 9 centimeters times 14 centimeters minus 4 centimeters, and all of this times 1.6, and that should give me 1.24, and that is the index of refraction of the liquid.